Is Crystal. I'll be, yeah. Okay, recording in progress. Hi guys, my name is Crystal. I'm a college student and I'll be your teacher for the next half of this class, so for the next 4 weeks. And I'll pretty much just be picking up where the previous guy left off. So, but if you guys have any questions, or if you guys have any questions about like previous material or anything like that, feel free to ask me. And if I'm like doing something like that is like not in line with like what he has planned, then also just let me know. But we're gonna start with a review of stuff from last week about strings. So does anyone remember what the difference is between the double equals sign and the dot equals method for strings? Y'all can just type it in the chat, or you can feel free to unmute and just talk. You don't need to like raise your hand or anything. Or if you guys just don't know, feel free to just say that too. If you don't know, then I can explain, but you don't. Okay, yeah, dot equals is more reliable, but why is it more reliable? That's okay. It's a little tricky. You have to pay attention to these things, like the difference between like dot equals and like the double equals. Like the rules for these also differ between like different programming languages, and it gets like really confusing sometimes. But yeah, equals compares the location. That's pretty accurate. So it's essentially like comparing like the object location, right? It's like checking whether like these two objects are like the same. So then what does dot equals compare if it's not the location? Yeah, exactly. The content of the strings. Nice. So then what are the differences between the following methods? Compare to, ignore case, and content equals. Sure, compare to, ignore case is pretty self-explanatory. It just ignores the case of the letters. What about the difference between compare to and content equals? Did you guys talk about content equals last time? If this is like something you guys didn't cover, then feel free to just tell me. Ooh, nice Pikachu background. Okay, no responses, so I'm just gonna assume you guys don't know. So compare to is between two strings, right? And generally, if you generalize it, it's just between two objects of the same type. So if you want to do compare to, you have to compare it to another string. However, you can do content equals with strings, like comparing strings to string buffers, or like string builders, any other kind of like string that is like similar to a string, but not actually a string, essentially. But compare to has to be between two objects of the same type. So yeah, that's it for the review. Any questions? Cool, moving on. So now we're gonna talk about the substring method. Oh yeah, and also feel free to tell me if like anything is like repetitive, like if anything is stuff that like you've already covered. Feel free to tell me that as well if you want to skip. But the substring method. So this has the form public string substring, right? So looking at this, we can tell that it's going to return a string to us. And so it takes in the arguments int begin index and int end index. And so it'll return a substring of this string that starts at the beginning index and goes up until, but not including the ending index. So here's an example. Here, I'll paste it into the chat for you guys. So you guys can copy it into whatever IDE you're using. And so looking at this string, what would you expect string Z to be if you tried to print it out? Does anyone have an idea? Okay, well, if nobody knows, that's fine. We'll just have to see what happens. I mean, a good way to figure out how things work is just trial and error. That's how people learn things in life. So let's run this and then we'll talk about what the outputs mean. Okay, so you can see that our original string was, hello all, we are now in the hall. And so string Z is x.substring 5. So what does this 5 represents the beginning index, right? This is the argument that we're passing in for the beginning index. And so which letter is at index 5? Can someone tell me that? I guess it's not a letter at all, actually. Yeah, it's a space. I just realized that was kind of a trick question, sorry. But yeah, the space is at index 5. So when we pass in 5 into this substring argument, that's going to be our beginning index. So it's going to start at index 5, which is the space, and then go all the way to the end of the string. So you can see here it printed out space all, we are now in the hall. Does that make sense? And then for the next one, we give it a starting index of 6, which is going to be starting with all. And then we go up until up to, but not including index 10. And so that gives us our ending bound. So here you can see we're starting at 6, 7, 8, 9. And then, but we're not including 10. Wait. 6, 7, 8, 9. Yeah, okay, I was right. Apparently I can't count today. But you can see that this includes indexes 6 through 9. So it's up to, but not including 10. 10 is the space that we are not including here. Does that make sense to everyone? Okay, cool. There are no questions, I'll move on. And then we also have the dot replace method. So this was pretty self-explanatory. It'll just replace. And then here, I'll also paste this into the chat so you guys can look at it. Okay. Let's make these look nice. And then print things out again. Okay. So replace method is pretty self-explanatory. It'll just replace all of the double L's with A's. So now we end up with a really weird sentence. Yeah, we are now in the ha, which is a very, very meaningful sentence. I'm sure you will hold it all in your hearts. And then this one, have you guys gone over the dot split method yet? Okay, well, no response. That's okay. So essentially the dot split method, right, splits the string along like whatever string that you give it. So in this case, we're giving it a comma. So it's going to split the string like into the part that is before the comma and the part that is after the comma. And it's going to essentially split it into an array. So here we can see that we have a string array called y, and this is going to be equal to x dot split. However, when we try and print it, it gives us this weird java.lang.string, blah, blah, blah. That's like the address of the object, right? Because it's not actually a string, so it's going to be annoying about being printed. But hopefully this will print what we want it to print. You can use like the toString method to convert things into a string. Okay, it is still not printing. That's okay. Essentially, what you should get is you would get like an array Y that looks like this, where you will have hello all as one string, and then you would have space we are now in the hall as your other string. So it essentially like splits the string along the comma and like takes everything to the left of the comma and everything to the right of the comma. Does that make sense? Okay, cool. I will move on then. Okay, so here's a little quiz question for you. So if we have the string, again, hello all, we are now in the hall. Write Java code to remove all the spaces in this string and then print out the new string without spaces. I'll give you guys a couple minutes to work on this. And then you guys can just like, if you guys could like maybe raise your hand or give any sort of reaction when you're done, and you should be able to, you guys have like the reaction option, right? So you guys can just give some sort of like emoji reaction or whatever whenever you're done figuring this out. And if anyone doesn't know how to do this, feel free to ask in the chat. Is anyone stuck? Or are you guys like all finding this a breeze or whatever? Okay, cool. Does anyone want me to give an explanation or like a possible solution? Because there are definitely probably multiple ways to do this, but okay, if nobody wants a more detailed explanation, okay, cool. Hooray. Wait, so do you guys want like the explanation or not? Okay, I guess I won't demonstrate, but just a short explanation is that like the way I would have done this is I would have used the replace method and I would have just replaced all the spaces with empty strings. How to private chat? If you go to the to section and then you should be where it says everyone. And then if you click on everyone, you should be able to see an option to direct message. Huh. Do you like not see the, that's weird. That's really weird. I don't know why that would be. Actually, wait, yeah, I don't have the option either. I don't know. Maybe it's something the host needs to enable. This I don't know. Miss Okay, she probably left. Sorry about that. But yeah, basically I would have just, one way to do this would just be to use the dot replace method. And so you could just do replace space with an empty string. And then if you run that, then that would get rid of all the spaces because you're replacing all the spaces with nothing essentially. So yeah, did anyone else do it a different way? I'm curious. Okay, cool. But yeah, okay, so next we're going to talk about string concatenation. And so concatenation is just a fancy word for saying adding things together, but for some reason in computer science, we love saying concatenation when it comes to strings. So it's essentially adding strings together. So you can see string X is hello all, string Y is how are you? So if you did X plus Y plus today, then it would become hello all, how are you today? Another way to do this is using the concat method. If you did X dot concat Y dot concat today, so the thing that you're passing into concat is going to become appended to the end of your current string. However, as you can see, this is a very annoying and non-intuitive way to add strings together, and it's just much easier to use the plus sign. You can also concatenate other kinds of objects with strings, and so usually in concatenation, they will get automatically converted to a string. So if you did string T equals hello and string J equals 200 and int I equals 100, so this is an integer. So normally if you tried to print this, Java would not be happy about it because it's like, oh, why are you trying to print an integer? You need to be a string, right? But if you add an integer or like any other kind of object to a string, it'll automatically turn that object into a string form. So if you try this, these tabs are annoying, but okay. And then let's print out. Let's comment that out for now. But like, let's run something like this. So you would expect it to print out hello 100, right? So even though this is an integer, it'll still be printed and added to the string. And so it becomes a string when you do that. However, if you try and do like int my int equals I plus j, right? And then you wanted to print out like my int, you can see that if you run this, you'll get an error. Right? So you get this incompatible types error, where it tells you the string cannot be converted into an int. Right? So you're trying to add I plus j, where I is an integer and j is a string. And even though there's a number inside the string, this doesn't work because Java's like, this is a string, you can't add it to a number. But so you can very easily turn numbers into strings, but it's not so easy to turn strings into numbers. You have to take an extra step in order to do that. So Java won't do that automatically. So when you have things like this, you can run into typecasting issues where like you want to have things as a certain type, but then like Java will be like, no, you can't do that, right? So here we have the integer.value of method and the integer.parseInt method. Have you guys gone over these before? Okay, well, I'll just explain them anyways. So the integer dot value of j and the both of these methods are going to essentially get the integer out of the string, right? So as you can see, both of these work. Both of these will print 300. And so they don't throw an error like just trying to add them directly does. So essentially what this is doing is this is taking in a string and turning it into an integer. So then you can add them together once they're both integers. And so the difference between value of and parse int, there isn't really a huge difference, but essentially value of returns like an integer object, like integer with a capital I, and parse int returns like an int with a lowercase I. So that's the difference, but it doesn't really matter that much. But as you can see, trying to parse int for something that isn't an integer, like say you wanted to do parse int hello, this isn't going to work because there isn't any number inside the string. So it'll just be like, what are you doing? So it gives an error cannot find symbol. So yeah, any questions on that or just in typecasting in general? Okay, cool. So here, the following are some important string methods to know. This is a screen cap about like string methods for the AP Computer Science exam. If any of you are interested in that, I recommend you take it. It's not a super hard exam, and I mean, CS is very useful. Although I'm sure you guys probably know that by now, or you wouldn't be in this class. But yeah, so here are some important string methods. These are like the big ones that you need to know, right? Int length returns the number of characters in a string, including spaces and special characters like punctuation. Substring method, like we talked about earlier, returns a string with the characters in the current string starting from the from index and going until the to index. And if the to index is not specified, it just goes to the rest of the string. Some other ones that we have not talked about yet. Index of, this one is handy. So this one returns the index of the beginning of like the string that you pass into it, if it's a substring of the current string. And it returns -1 if it's not found. This explanation is a little confusing. I'll show an example later. And then this one is the compare to method. And I think we've talked about this one before, right? Because I think you guys knew what I was talking about when I was talking about it earlier at the beginning, but essentially the compare to method returns a negative value if the current string is less than other, 0 if they have the same characters in the same order. So essentially if they're equal, and a positive value if the current string is greater than other. And so essentially for strings, this is basically based on alphabetical order. This is actually based on the ASCII numbers of the characters in the string. So like if you convert like a char to like an int, like I think a capital A is like 64, like that's the number. So it actually is like, it does like a numerical comparison of like the characters in your string to determine which one is first in the alphabet based on the ASCII numbers. So that's pretty cool. And then we have the equals method, like I talked about earlier. Returns true when the characters in the current string are the same as the one in other. And like I said earlier, this one is inherited from the object class, but is overridden. So it means that the string class has its own version of the compare to method, but I mean, sorry, not compare to, equals. Although compare to is also a popular overridden class, but the equals method. So this is what I was talking about earlier, how like equals is more strict, I guess, than like the content comparison. What was it called again? I don't remember. But the point is, this one is more strict because the two objects have to be of the same class. So in this case, they would both have to be strings. Yeah, hold on. Before we do the quiz, let me just demonstrate index of really quickly, just in case you guys do not. Have you guys talked about index of before? Because if you have, then I can just skip it. But Okay, no responses. So I'm assuming that you guys want me to continue with this. So let's say int index is equal to x dot index of, give me a letter.
9.
None, no letter.
9.
Oh, 9?
Yeah.
Okay, wait, give me a letter that is in this string. Actually, no, wait, we can do 9. We can do 9. Although 9 is a number, not a letter. But we can do that. Oops.
Shouldn't it give you the 9th letter?
No, you're getting the index of a certain substring. So you're trying to find what the index of like a certain string is. So here, let me try something else first. So if you put in like A, right, it's going to find the index of the first A in this string. That's what it's going to return. So you can see in this case, it returns 6 because the index of the letter A is 6 in this string. And there are other A's in the string. Obviously, you can see that there's 3 A's total, but it essentially returns the index of the first A in the string. Does that make sense? So yeah, so if we put in something like 9, like you said earlier, as a string, it would essentially return -1. And so when something returns -1, this is a common programming practice, but in general, if like a function returns -1, that means something like isn't working. So as you can see, it returned -1 because there is no 9 in this string. So it's telling us that this substring doesn't exist. You can also put in things that are longer than a letter. For example, you could put in the word, or you could put in LL. And you can see that the first one would be at 2, but there's multiple LLs in the string, but it returns index 2 because here's the first one. So it searches for the first place that this substring appears, and it returns the beginning of that string. So notice that it returns a 2, which is where this one starts, instead of a 3, which is where it ends. Does that make sense? So it's returning the beginning of where this substring starts. Okay, cool. There are no more questions on that, then we will move to the quiz time. I was gonna make a Kahoot for this, but then I ran out of time because I had work. Because this class is like right after I get off work. So, but what is the value of pause after the following code executes? Feel free to just put your answer in the chat. Yeah, Selena is correct. The answer is 1, which would be B. Remember that strings and everything else in Java starts from a 0 index. So the first letter would be 0, and then the second letter, which is B, would be of index 1. So that's why it's 1 instead of 2. Any questions on this? Cool. Next one. Any guesses? I really should have made this a Kahoot, honestly. But yeah. The answer is 9. I mean, this is pretty simple. You just count 1, 2, 3, 4, 5, 6, 7, 8, 9. Next, what is the value of S2 after the following code executes? Yep, D is correct. So it goes from 0, it goes 0, 1, 2, and does not include 3. So 0 would be correct. I mean, not 0, sorry, D. What do I say? So BAB would be correct. Nice job. Okay, what is the value of S2 after this code executes? Huh? S equals D? What do you mean? Oh, D. Why do you say D? Like, what is your thought process? That's okay. It's okay if you're just guessing. But yeah, Selena's right. The answer is A. So when you only have one argument in the substring method, that argument represents the first index. So you're starting from index 2, which is this B. And then wait, you guys can see my mouse, right? If I'm hovering over this. Okay, well, anyways, it starts from index 2, which is this B, and then it basically just goes all the way to the end of the string. So there's essentially like no, because there's no end index, right? So it starts from here, goes to the end of the string. In this case, the end of the string is just one more letter. So it would be B or by, I guess. Does that make sense? Cool. Next question. What is the value of S2 after the following code executes? Any guesses? It's okay if you guys don't know. You can just like write don't know in the chat if you just want me to cut to the chase and start explaining. Yeah, A is correct. Nice. So as we're looking at this, right, we get our int pos, which is s1.index of E. In this case, the index of E is 0, 1, 2, 3, 4, 5. So then we get 5. And then we want our substring from 0 to 5. So starting at 0, which is 8. Oops. 0, 1, 2, 3, 4, 5. Don't include 5, so it would just be 0 to 4. So high TH. Another way you can also look at this just really quickly without having to count is you can look at this like conceptually, right? Looking at this, you know, oh, pause is going to have the first index of E, and then string 2 is getting the substring from 0 to the first index of E. So then you don't even need to know that the index of E is 5. You can just look at this string and go until the first E, and then that's your substring, right? So then you don't have to like spend time counting. So this especially gets like, you know, useful when you start looking at more complicated code. And so you just need to understand like conceptually what the code is doing instead of worrying about like the indices and like the little nitty-gritty details like that, right? So then you can just look at the code and understand like what is it trying to do based on just like what these methods are. Okay. What is the value of S1 after the following code executes? It's not B. Remember that, yeah, it's A. Remember that for the substring method, right? We're starting from the first index and going up to, but not including the second index. So here we have 0 and 1, right? It starts at 0 and then it goes up to, but not including 1. So that just ends up being 0. So then you end up with a capital H, then to lowercase, it becomes a lowercase h. Does that make sense? Yeah, D, sorry. I don't know why I said it was A. It's D. You're right. Clearly, I do not know my letters. This is what happens when you do computer science and you spend a lot of time staring at letters. But yeah, so D is the correct answer. It would be a lowercase h because you're taking the substring method would just give you the uppercase h and then you would put it to lowercase. So now let's talk about another kind of a string class or a string related class called string buffer. So the main thing about strings and the main limitation on strings is that they're immutable, right? So they can't be changed after you make them. And so this can be really annoying and inconvenient sometimes when you're trying to program and you want to be able to add things onto your string or like take things away without like running into like annoying Java memory issues, right? So to help it with handling strings, we have a new class called string buffer. And so a string buffer is essentially like a string, except for it's mutable. So you can change it and you can extend it and write to it. So string buffer allows insertion of substring in the middle or at the end of your original string, and it will automatically grow to make room for anything you add to it. And so because of this, in order to make this automatic growth easier, it'll often pre-allocate characters, like allocate more characters than it actually needs to allow room for growth. So if you think about like when you normally like store things like on a computer or just like even like in your room, right? If you had like a box full of like a bookshelf of bookcases, right? And so if you think like of each book as like a character in your string. So normally when you make a string, your computer will make a box that is just big enough to hold that string and like no other letters, no other books, right? So then if you wanted to make if you wanted to add stuff to that string, you'd have to make a new box essentially, and then move all of your books from the previous box to the new box and then add your new books in, right? And so this is really annoying And so essentially the point of a string buffer would be just starting with a bigger box. And so you'll still have the same amount of books in the box, but you're starting with a bigger box. So then when you try and add more books, you don't have to create a new box. Does that make sense? Okay, so here's the constructor for a string buffer. So the default constructor would just be no arguments. And so this reserves room for 16 characters without reallocation. So doing string buffer s equals new string buffer, that creates a string buffer that has space for 16 characters, but it's still an empty string. You can also create a string buffer and give it a size argument when you construct it. And so this will accept an integer argument that explicitly sets the size of the buffer. And so in this case, like in computer science in general, we use buffer to kind of refer to like how much space you have, right? So the buffer, the size of the buffer is like how big your box is, how many books you can fit in your box. And so here we're explicitly saying we want a box that has space for 20 books, right? Instead of the default, which is 16. And then another option for making a string buffer is to pass it an initial string. So in the previous ones with the size argument and the empty string buffer, we're creating a box that is a certain size, but the box has no books in it, right? With this argument, if we're passing it a string, we're essentially giving it books to start with. So it accepts a string argument that sets the initial contents of the string buffer object and then reserves room for 16 more characters without reallocation. So essentially, if you pass in like string buffer hello, right? Hello has 5 characters. So then it would create a box that can store 5 plus 16 or 21 characters. And then it puts the 5 characters in that box. So then you now have a box with hello in it and also space for 16 more characters other than your initial hello. Does that make sense? Cool. Okay, and this one's pretty self-explanatory. It's length. It returns the length of the string in the string buffer. However, these two, make sure you don't get these two mixed up. So length is the string in the string buffer or how many books you have in your box. Capacity is the total allocated capacity or how many books you can have in your box. Like how many books do you have space for? And then length is how many books you actually have. Does that make sense? Cool. Okay, so here, let me paste this into the chat so you guys can run this on your own computers also. So we have this where we're making a new string buffer. And so we're calling it AOE Java class, right? And so we're going to get the length and the capacity and then print them out. And you can see we will expect that the capacity is 16 bigger than the length. So as you can see here, it does what we expect it to. So, which is always nice in programming when things go how we expect them to go. So this is the length of the string is 14. And then you can see that the capacity is 30, which is 16 more than 14. Okay, now I want you guys to spend like maybe 5 minutes or so clicking around on this website. And I'll point out some highlights too. But this website is essentially describing the string buffer class. The really nice thing about CS is that you can find everything you need to know about it, like really well documented online, and Google things yourself. So I want you guys to look through this website and tell me what is a method that can add a character to the end of a string buffer, and how can you convert a string buffer to a string? I'll give you guys 5 minutes to try and find the answers. And then if you guys, once you guys find them, you can type them in the chat. And then if you haven't found any by the end of the 5 minutes, or if you're just really confused even before the 5 minutes end and you just want me to tell you guys, then I can point them out to you. Here, let me go back to this slide so that you guys can remember what the questions are. What are you using? So are you saying you use replace to get the string, to convert the string buffer to a string? Oh, okay. Yeah, you could. I don't know. I actually don't know if that would work to add something to the end. This would definitely work to edit stuff in the middle, but I'm actually not sure if you can use this to add stuff to the end of a string buffer. Because you would be, oops, drag this somewhere. Because you would end up restricted to what you currently have in the string. Right. So like you can't add like you can't replace things that like don't already exist, right? Like if you have 5 books, you can only replace like these 5 books. You can't add a 6th book by using replace. Your ending index is still 5. Even if you have space for 10 books, if you only have 5 books, your ending index will still, like the max index in your box is still going to be 5, even though you have space for 10. You can't, okay. The thing with buffers is that you can't like access the extra space, if that makes sense. I don't know how to, like, you can only access like the books. You only have control over the books. You can't like replace the extra space because that's not like part of like what you can access. I don't know if that makes sense. Like the extra space doesn't have an index. So how are you going to address it if it doesn't have an index? There's another way to do this. Yeah, append. The first method on here. Hold on, someone's knocking on the door. Let me get that really quick. Sorry. Okay, sorry about that, y'all. But yes, append is correct. It's used to append the specified string with another string. So the append method is overloaded. Like, so you can append like multiple kinds of things like chars, booleans, ints, floats, whatever. So it doesn't have to be a string. You can append anything, but yes, you use append. And then when you append it, it gets converted into a string. Does that make sense? It's like you don't like have like direct control over the buffer because like it doesn't really have like an address or anything that you can like get to. So you need to like append something first in order to add things. But yeah, what about how to convert a string buffer to a string? Does anyone have any ideas? This one is, yes, that's true. That does work. What about something that is on this page? It's actually, it's less straightforward than using toString. This is just a slightly more creative way of doing it. But toString would work, yes. And toString is probably the preferred way to do it. But what's another way that you can see based on what's on here? It's a little bit tricky, so it's okay if you can't think of it. I'm just trying to get you guys to, like, I guess, think outside the box a little bit with these methods and what you guys can do with them, other than like strictly what is listed. Okay, I'm just gonna tell you guys because otherwise we're gonna run out of time. So the other thing you could do is you could use the substring method. As you can see here, you can see that the heading is public string. So that means that this method is going to return a string to you. So then you can actually get like, use the substring method and just use the substring method to get the entire string. If you put in a beginning index of 0 and an ending index that's just the end of the string, then you're just gonna get the whole string out of it. So that's another way to do it. But yeah, toString is probably the better way. Any questions on that? Okay, another quiz question. Write Java code to reverse this string buffer and then convert it to a string. You can type it in the chat. Yep, yeah, reverse is the first thing that you do. And then to convert it to a string, we already went over this, but just type it into review. But make sure you do like, you need to do s.reverse, right? Not just reverse. If you just do reverse, it doesn't like, it's not attached to any object. you need to do s dot reverse so that you're reversing s. And then similarly, you do s dot toString. Does that make sense? So then the methods are acting on this object. Yeah, system.out.println. And then usually you want to convert it to a string before you print it. Or you can do system.out.println and do s plus an empty string. And so this is also a really common way to print things out, is to just concatenate it with an empty string, because then that automatically turns the previous object into a string. Essentially, what's going on behind the scenes is that it's actually calling the toString method behind the scenes, like in like the compiler. Like when you type it like that, the computer actually sneakily calls toString when you concatenate a non-string with a string. But yeah, you would want to convert your string buffer into a string before you try and print it. Otherwise, like you saw before with like my array, right, that we were trying to print out, it'll just print out the object location, which it can be helpful sometimes. But in this situation, it's not very helpful because we want to see what's inside the object, not where it is. But yeah, okay. We don't have a lot of time left, but that's okay. This isn't very important. This is just the string builder class is another class that deals with strings. It's very similar to a string buffer in that it's mutable and can grow. The difference is that string builder does not guarantee synchronization, and therefore it is not thread safe. However, it is faster than string buffer, so that's like the trade-off there. But I'm not going to explain what it means to be thread safe or synchronized, because that is way beyond the scope of this class. So just remember that they are pretty much the same thing. And so you can use string builder wherever you use string buffer. And so here are just the methods for string builder. They're pretty similar to string buffer. Okay, so here's the homework. I have the following sentences. Please compare Tom and Mary in the classroom. So I want you to use the substring method to get the names Tom and Mary out of these strings and assign them to variables name1 and name2. However, you should not hard code the values of Tom, the index values of Tom and Mary. So don't do like dot substring, like what is the, let's pretend Tom starts at index 10. Don't do like s dot substring 10, 13 or something like that. I don't want you to like hard code the values in. I want you to get the values using the index of method, if that makes sense. So using index of, find out where the Tom starts. And then you can also, and then use that value to get your substring. So then if I give it a different sentence where Tom and Mary are in different places, you should still be able to get the right answer without changing your code. And then I want you to find out the length of both the length of both names and print out the bigger length value. And then print out whichever name comes first alphabetically. And so these two comparisons should also work no matter what names you assign. So they should be coded in and not like just you printing out Mary because you know Mary comes first. So in order to submit these, just send me either screenshots or like a file or just like your typed up code in Google Classroom. And I'll obviously post the PowerPoint afterwards, but yes, any questions about the homework? I know I think the description is a little bit confusing, so are there any questions? You can also just ask me questions on Classroom later if you're confused about what I mean. I couldn't find like a less confusing way to word this. Okay, cool. Well, if there are no questions, then we are done for today. I'm like 1 minute over, but that's fine. Yeah, there are no questions. You guys can leave. Have a nice day. Hope you understood everything I was saying today. Raymond, do you have any questions? Okay, nope. Miss Huh, are you there? Hello, Miss Huh? Okay, I'll just end the meeting then. Bye.